Hello again, everyone. Today we're going to talk about something called spontaneous reactions, and we're going to use one of our reference tables. So get out your reference tables and turn to table J, and that's going to help us figure out if reactions are spontaneous or not. So for the notes today, I have some fill-in notes attached to the assignment. So if you want to print those down, download them, and mark them up digitally, or you can just write this stuff on a piece of paper. If you don't want to print anything out, that's fine. So what are spontaneous reactions? Spontaneous reactions are reactions that proceed on their own without any outside intervention. So nothing really needs to be done to get that reaction to occur other than to just put those substances in contact with each other. So once they're in contact with each other, they react. All right, so that's a spontaneous reaction. A non-spontaneous reaction would be something that you need to do more than just put the substances in contact with each other. They need something to get the reaction going. So those are non-spontaneous reactions, and we'll talk about those later on. But spontaneous means once they're in contact with each other, they react. So nothing more is needed. Okay, so that's a spontaneous reaction. So table J is going to help us out in figuring out if reactions are spontaneous or not. And it's really not that complicated. So table J. So what does table J show us? So let's take a look at table J. So here's table J. And as you can see, we've got two columns, metals, nonmetals. So on the left, we have all these metals. These are all metals, except for this guy right here. Remember, hydrogen is not a metal, and we'll talk about that in a little bit, but just recognize that at this point. And then here's a couple nonmetals over here, and look what it tells us here. Most active are on the top, and then our least active are on the bottom. So active, or think about active is the same thing as reactive. So these are synonyms here. Active and reactive. That's just how quickly these substances enter a chemical reaction. So that's reactivity. How quickly, how easily they enter a chemical reaction is reactivity. If something that's highly reactive, it enters a chemical reaction very easily. All right, so what does table J show us? So a more active metal will replace an ion below it on table J. So like we said, the higher metal is more active. So the higher metal is going to replace the ion below it on table J. So here's an example. So if we have nickel and chromium, so look and say, okay, who's the ion? So right here, here's nickel all alone. So no charge. So it's an uncombined element. So think about your uncombined elements. So the uncombined element has to be higher than the ion in order for it to be spontaneous. So let's go back to table J and compare nickel to chromium, right? So find them. Here's nickel. And then where's chromium? Chromium is right here. So nickel is not above chromium. It's below chromium. So that means it's not strong enough to react. All right. So no reaction. It's that simple. All right. So now let's look at the next example, calcium versus magnesium. So again, go to your uncombined element and you want to see, is that higher than the ion? If it is, that means it's more reactive and you'll get a reaction. If it's not, no reaction. So we go back to table J, find magnesium versus calcium. Here's calcium and here's magnesium. So calcium was the uncombined element. So that's higher. So it'll react spontaneously. So we get a reaction. All right. So that's all we're really looking for. Will a reaction occur or not at this point? So now where do these ions come from? Remember, this is another instance where it's not showing us the whole picture. So remember what your ionic compounds do. Say I have some magnesium bromide. So that's going to go into solution and break up into magnesium ions and bromide ions. So another way you might see this expressed is if they just said, okay, if I had some MgBr2 is reacting with calcium, all right? So now, is calcium strong enough to knock out magnesium and replace it. So that just brings us back to single replacement reactions, which are coming up. But this is just another instance where they're not showing us the whole picture, just like in those redox reactions that we have to balance a particular way. So think of these ions as if they're in a compound, but we just don't know who the other ion is. So when there's no charge, those are uncombined, all right? So think of these as uncombined. This is your uncombined element. And think of these guys as in a compound, all right? And is the higher one, if the uncombined is higher than the ion or the one in the compound, it's strong enough to replace it, so you'll get a spontaneous reaction. If it's not higher, it's not strong enough, so you don't get a spontaneous reaction. You're not going to get any reaction unless you do something more to get that reaction going, all right? So it's that simple. So a more active nonmetal will also replace an ion below it on table J. The same thing, but there's not that many nonmetals on table J. So you're really mostly going to get questions about the metals. So, and all of our nonmetals on table J are Brinkelhoffs. So they're all two stuck together, I2, Cl2. So again, this is the uncombined, right? That's our uncombined. And then this is the one that's in the compound, right? The ion is in a compound. Again, we just don't know who the other ions. They're not showing us the whole picture. Sometimes they do, and you'll see that in a minute. So now is same rules. Is iodine higher than bromine? If so, you'll get a reaction. If not, no reaction. So again, we go to table J. Iodine is not higher than bromine, so no reaction. All right, and then if I compare chlorine to bromine, same thing. Chlorine, though, is higher than bromine, so we're going to get a reaction. So go to our table J. Chlorine is higher than bromine, so we get a reaction. That's it. So that's really as hard as it's going to get right now. And again, you remember, this is addition. Addition is commutative. So it doesn't matter which way these reactants appear, who's first. You just always want to compare the uncombined element to the ion. So this and this are the same thing, right? Chlorine plus bromine and bromine plus chlorine are the same thing. That's like 2 plus 3 or 3 plus 2. Doesn't matter. They both equal 5. All right. So just look for the uncombined element, and you want to compare that to the ion and see if it's higher. If it is, you get a reaction. If it's not, no reaction. That's simple. So now moving on. Any metal above hydrogen will spontaneously react with an acid. So remember what acids are. Acids produce H plus, right? Acids produce H plus ions. So acids have hydrogen in them. So think back to our acid metal reactions. We've talked about this earlier on in the year, back in the acid base unit. So when an acid and a metal react, you get hydrogen gas and salt. So we've done a lab with this. You get the gas production, and we lit it on fire, and it did a little pop inside the test tube. So that's when an acid and a metal react. So as far as we were concerned before, acids and metals react. But not all metals react with acid. Only the ones that are more reactive than hydrogen, that are above hydrogen on table J, are going to react. So that's not that complicated, all right? So we want to, again, is the uncombined metal higher than the one in the compound? So now in this case, we're going to see, is magnesium strong enough to knock out hydrogen and replace it? That's really all that's going on here. Is it's really just a single replacement reaction. This is just a special type of single replacement reaction. So let's go to table J and compare magnesium to hydrogen. So here's magnesium, and here's hydrogen. So magnesium is higher so it's more reactive, so it's strong enough to replace it. So now we want to do a little bit more than just say a reaction is going to take place. We want to predict the products because we know who our products are. Acid plus metal makes hydrogen gas and a salt. So remember what a salt is. That's just your ionic compound that's forming. So what do we get here? Well, we know one of our products is hydrogen gas, right? So magnesium is going to knock out hydrogen and replace it, single replacement. So now hydrogen's all alone, but remember it's H2 because it's a Brinkelhoff, two stuck together in its elemental state. And then what's our other product? We can't just mush Mg and Cl together. Remember, we got to write them off to the side, assign charges, and crisscross. So our other product is MgCl2. We're done. So we determined the reaction would occur spontaneously, and we've done this. Magnesium and hydrogen and hydrochloric acid, we've put those together, and they react. We got our hydrogen gas that bubbled, and we also get some magnesium chloride that's produced too. So now what about copper? Will copper react with hydrochloric acid? So let's go to table J and see. So is copper higher than hydrogen? So here's hydrogen. Copper is not. So copper is not strong enough to react spontaneously with an acid. So if I plunk a penny into some hydrochloric acid, it's not going to react. So if we were in class, I would show you this, but we aren't. So I'll just tell you about it. So copper will not react with an acid because it is not strong enough to replace hydrogen. Now look at these metals that are below hydrogen: copper, silver, gold, right? These are metals that we like to make things out of. You know, copper wire is in the walls in your house. It conducts electricity. Silver, gold, we make jewelry out of those because look where they are in this activity series. They're very low. So they have a low activity or reactivity. So they're not going to react very easily with substances they come in contact with. So they're going to stay nice and shiny for a long period of time. So that's why we like silver and gold for jewelry, because they stay shiny. And copper, that's why we like to use it for certain things like conducting electricity in the walls of your house, because it's not going to react. Because if they react, they corrode, and that increases the resistance of the metal, and then that heats up in your walls and you'll get a fire. We used to use aluminum, and a lot of the Levittown houses used to have aluminum wiring in them, but look where aluminum is on the activity series. It's higher up. So aluminum is more reactive. So what would happen is over time, the aluminum wiring in your wall would corrode, and then the resistance would increase, and you would get electrical fires. And it was a big issue. So a lot of your houses, you can even ask your parents if they might have done it. They might have had the aluminum wiring changed and upgraded to copper, or it was done by the previous owners or something. But most of you, probably all of you, have copper wiring in your walls now, but originally they had aluminum wiring. But that's chemistry, right? It's all around. So let's go back to this. So now copper, we said, is not higher than hydrogen, so no reaction. So if I plunk a penny into some hydrochloric acid, it's not going to react because the copper is not strong enough to replace the hydrogen. So then same thing that we've been doing, right? Same rules apply. The uncombined element has to be higher than the one in the compound. If it is, you get a reaction. If not, no reaction. That's simple. So the higher the metal on table J, the more readily the replacement will take place. So what does that mean? That just means it's going to happen faster, right? So if it's higher up, it's going to react even more vigorously. And the other thing you want to remember is that hydrogen is the standard used to determine the reactivity of metals. So even though hydrogen is not a metal, it's on table J here, right? Here's hydrogen down here. So why is hydrogen on table J and it's not a metal? Because we use that as our gauge, right? We compared all of these other metals to hydrogen and looked at how readily it reacted with hydrogen. So that's how we came up with this reactivity series. So even though hydrogen is not a metal, and it even tells you on the bottom, activity series is based on the hydrogen standard. Hydrogen is not a metal. So remember, H is a non-metal. Even though it's above the group 1s on the periodic table, we still consider it a non-metal. So it was just a standard that we used here to determine the reactivities of these other metals. All right, so don't forget that. All right, so last thing here, single replacement reactions. We pretty much talked about already, but now they can sometimes show you the whole picture. So like I said in the beginning, sometimes they don't give you the whole picture, sometimes they do. So basically the same concepts that we've been talking about apply here. So the more active metal will replace the less active metal in the compound. So the uncombined element must be higher than the one in the compound. So same thing over and over again. So now that we have the whole picture, though, we can predict the products. We don't just have to determine if the reaction occurs or not. We can see who the products will be. So is zinc higher than copper? So metal is going to replace metal, and if there were a non-metal, non-metal will replace the non-metal. So let's go to table J and see, is zinc higher than copper? All right, here's zinc. And yes, it is. So that means zinc is strong enough to replace copper. I keep doing that. Zinc is strong enough to replace copper. So boom, zinc will knock copper out. And then copper's all alone. And now who's my new salt? So we got to figure things out. So again, write your ions off to the side, assign charges, and crisscross. So our new product is ZnCl2. Don't just assume that the ratios are staying the same, right? Write your metals, give them the charges, and do the whole crisscross thing that we've been doing all year to ensure that you get the right ratio of atoms in the compound. All right, so these are your products. The next one, magnesium and barium fluoride. So is magnesium strong enough to replace barium? So we go to table J. And here's magnesium, and here's barium. Nope, magnesium is not strong enough to replace barium. Barium is stronger, so no reaction. So pretty simple. So when a reaction occurs, the higher metal is oxidized and the lower metal is reduced. So the higher metal gets oxidized and the lower metal is reduced. So just keep this in mind. The higher metal gets oxidized. So that's going to help us out when we move on later on in this unit to the next part. Start this. All right. So just keep that in mind as we move forward. The higher metal gets oxidized. What is oxidized? Loss of electrons. So that's the one that's going to lose electrons, Leo. So just keep that in mind as we're going forward. Okay, so let's sum things up quick before we move on to some practice problems. So let's jot this down. So if the uncombined element is higher on table J than the element in the compound or the ion, then it's a spontaneous reaction. All right, so remember what that means. It's going to happen all by itself without any outside intervention. All you have to do is put the two substances in contact with each other and you'll get a reaction. So remember who replaces who. So Metals replace metals. Or hydrogen, if we're talking about acids, metals reacting with acids, and hydrogen's kind of going to act like a metal, so the metal will replace the hydrogen. And nonmetals replace nonmetals. All right, so just keep this last bit in mind here. Kind of sums everything up nicely. So now let's take a look at some practice problems. So why don't you pause the video for a second, try these problems out, and then we'll come back and go over them. Okay, so let's go through these problems. Number one, which element is used as a standard for comparing the activity of metals? So pretty simple. That's hydrogen. So that's hydrogen. We went over that before. Hydrogen is the standard. Even though it's not a metal, it shows up on table J because that's who we are comparing all of these other metals to determine how reactive they are. Number two, in which of the following is the more active metal listed first? So all you're doing here is going to table J, looking at all these and seeing which one is the higher one first. So really simple. The answer is 3. Lithium is the one that's higher than calcium, so that's the one that's in the correct order. All right. Number 3, based on the activity series, which of the following is most likely to occur? So when it says that, that means spontaneously. So you want to look through and see in which of these is the uncombined element higher than the element in the compound that it's going to replace. All right. So we want to see, is iron higher than hydrogen? Is magnesium higher? Is zinc higher than magnesium? So the uncombined, we want that to replace the one in the compound. Is aluminum higher than barium? Right? And here we want to see, is hydrogen higher than lithium? So we go to table J and we look that up. So the answer here is choice 1. Iron is higher than hydrogen. All right. So if you look on table J, I don't have to keep clicking back and forth to it, but you'll see iron is higher than hydrogen. So it's going to knock hydrogen out and replace it. Zinc is not higher than magnesium, so it's not strong enough to replace it. Same thing with aluminum. It's not higher than barium. And hydrogen is not higher than lithium, so you won't get a reaction. So next up, number 4, based on the activity series, which of the following metals could not replace any of the others? So all that's really asking you is which one is the lowest of the 4. So it's saying it cannot replace the others. So that means it's not higher than any of the others. And if you look on table J, you'll see aluminum is the lowest of the 4. So take a look on your table J and see aluminum is the lowest. That means it's not strong enough to replace any of the other ones if they were in compounds. Number 5, the standard on which the activity series is based. Again, it's a repeat of question 1. So make sure you know this. It's hydrogen. So hydrogen is the standard that we're dealing with here. Next, number 6, during a single replacement reaction, which of the following is true? So that's 2. The more active metal is oxidized, the higher metal gets oxidized. We said that before, so keep that in mind. Remember that. Number 7, during the reaction, which ion was reduced? So this is a trick question. The answer is 4, none of these. Why none of these? Because this is not a redox reaction, right? There are no uncombined elements, right? So if we went through and assigned oxidation states to all of these elements, nobody's changing. So this is not a redox. There is no movement of electrons. So nobody's oxidized, nobody's reduced. Trick question. So don't forget how to identify a redox reaction. We're looking for at least one uncombined element. Number 8, which metal will react with Pb plus 2 but not with Mg plus 2. So what does that mean? So it's saying, okay, if it'll react with Pb plus 2, this is the ion. So we're dealing with our uncombined metal. It has to be higher than lead, but it will not react with Mg, so it's got to be lower than magnesium. So we go to table J and we want to say, okay, who's higher than Pb but lower than magnesium? So where's Pb? Here's Pb, and here's Mg. So who falls right in the middle of these guys? Aluminum, right? That's our choice there. That's our only choice that falls in between those. It's higher than Pb, so it'll react with Pb, but it won't react with Mg. So the answer there is choice 2, aluminum. The other three are not between the two. Number 9, if the reaction X plus zinc plus 2 makes X plus 2 is spontaneous, then who might X be? So it's just saying, okay, here's your uncombined element. So which of these 4 choices is higher than zinc? And the answer is magnesium. The other 3 choices are lower than zinc. Take a look on your table J and you'll see. Which metal can reduce Pb plus 2? So that means it's getting oxidized. So the higher metal is oxidized. So it's basically asking us which metal is higher than Pb. Remember, the higher metal gets oxidized, the lower metal gets reduced. So it's basically just saying which one is higher than Pb. And of these 4 choices, iron is your answer. All right. So again, this is one of those cases where if you get a multiple choice question like this, you can use the tactic of which of the 4 choices is different to make the most educated guess. If you're a little bit lost and you're not sure how to answer this question, if you look on table J, you say, okay, iron is above Pb. The other 3 choices are below Pb. So iron's kind of the odd man out. So that's the one that's different. So that's the choice I'm going to go with. Ideally, you'd be able to answer this question without having to resort to that. But if you did, that's a good strategy to use here. All right. So that's it for today. And I will see you all next time.